kind of a goofy day. First time in my teaching career that I've ever been let out for a tornado early, and turned out that they were right. Okay? So they were justified in their wanting to get you home safe, get you home early. Good thing. So today I'm going to shorten up the lesson a little bit because the majority of you haven't taken the quiz. Of all of my students, I had 3 of them that actually took the quiz because they don't have me on Friday. They had me earlier in the day on Friday. Okay? So I'm going to shorten up the lesson today a little bit. And we're going to take the quiz the last half of class today. Okay? And then so that you get that done and get that turned in and get all caught up. Because we got to do it today because the test is this week Thursday. Okay? So your test is this week Thursday. So today we're going to finish up 8-7, couple of quick constructions. Then tomorrow 8-8, couple of quick constructions. Then Wednesday's going to be a review day. Thursday's a test day. Friday we start unit. Okay? All right? So if you haven't gotten a compass yet, make sure you have a compass. If you haven't gotten out your straight edge yet, make sure you get out your straight edge because you need to have that done too. Okay? All right? So here we go. Construct a circle with center at point A and a radius length of AB. Then construct a circle at center at point C with radius CD. Should be the same. Should intersect at the. All right, well, let's do it. Okay, so retrieval. So figure ABCD is a rhombus. Use a straight edge to draw the 2 diagonals. Okay? Fairly straightforward. Let's draw our 2 diagonals. Oops, I'm off. Okay. Using a compass, construct a circle with the center at point A. So pointy end goes at A, okay? And then we extend it out to B, right? Okay, so pointy end at A, extend it out to B. Okay, and then draw your circle. Then it said, construct a circle at point C. So now I'm moving my pointy end to point C. With length CD. And what do we notice about those 2 circles? What do you notice about the intersection points of those 2 circles? Pink circle and green circle, where do they intersect? At point B and point D, the other 2 points of the rhombus, right? Yeah. Now, logically, does that make sense? Would this work? Same thing on a rectangle. Would this work on a parallelogram? Or conversely, why does it only work for a rhombus? Talk about it at your tables. Go, talk. Why does this work for a rhombus? Why wouldn't it work for anything else? Talk at your tables. Go. Somebody give me an idea of why it works from your table. Or what? All the side lengths of a rhombus are the same, right? And what's our radius? Our radius was a side length of the rhombus in both of them. In the pink circle, the radius was side AB. In the green circle, the radius was side CD. Both of those are the same because it's a rhombus. Okay? Right? So both of those are the same. It only works in a rhombus or a square, okay? But only in those two. Okay? The only difference between a square and a rhombus is a square has perpendicular sides, or perpendicular angles, I should say. Yeah? All right? Love it. So examine the diagram. Points M and N are the center of their respective circles. Okay? Ooh. Give me a congruent statement would be like side BM is equal to side BM. Okay? Or it's congruent to BM. Okay? That would be a congruent statement. Okay? Give me one congruent statement out of this diagram. CB congruent to AB? Okay, I would agree with that. Somebody give me a different one. CM congruent to AM? Another one? Can I say that one? What gives me the right to say that one? No. Because it's a triangle. So it's got to be one of our letters ones. Reflexive property would be BN congruent to BN. Why can I say those two triangles are congruent? Five choices are. What are my five choices? We've recited them before. What are my five choices for triangles being congruent? Side's one of them. What's another one? Angle, side's another one. What's another one? Hypotenuse length, but that one only works in right triangles. Two more. Angle, side, angle. And somebody else? Side, angle, side. Side, angle, side. So which one of these is that? It's a side case. Yep. Okay. All right. Love it. Let's get into some constructions here now. Okay. So, constructing a rhombus. Okay. So that's what we're going to do first. We're going to construct a rhombus. Okay. Now I'm going to give you steps based off of this diagram, this A and B diagram. Okay? Okay? So step number one is, with your compass, measure side length AB. Okay? Got it measured? Swoosh it. Okay? That's going to give you point C. What do you know about AB and BC? They're congruent, right? Which is good because we need them to be congruent in a rhombus, right? Okay? So now I'm going to move the compass to point A, and I'm going to swoosh somewhere in the middle here. Okay? Doesn't have to be a very big swoosh, but I'm going to be somewhere in the middle of that angle is where I'm going to swoosh that one. Then you're going to move the compass to point C, and you're going to swoosh that one. That's going to give you point D. Because you didn't change the opening on your compass at all, point A, point B, point C, and point D are all equidistant from each other. So therefore, that is your rhombus. If we change the openings, then it's not a rhombus anymore. Okay? Now, if this were a quiz question from last week, or if, well, from Friday, if you would have taken it, or if this is a test question on Thursday, what I'm grading is these three things right here. I would need to see all three of those intersecting arcs in order to get credit for this one. Otherwise, you're just drawing it to draw it. You're drawing it freehand. And we are constructing. So I need to see tick marks or swooshes, if you will, in order to get credit for any and all constructions. Okay? Oh, I gotta find where it is. We know how to do a perpendicular bisector, so I'm not worried about that one. I want to, there we go. I want to make this, label the point, all right, MS, one side of the square. All right, so we want to make a square out of this one, okay? Truth be told, we're just gonna make a square out of some random, so if you wanted to, you got plenty of space on there. I'm not gonna do those two examples. We're just gonna make up our own, okay? So I'm gonna teach you how now to make a square. Okay? So I just have a line segment AB. Okay? First thing that you've got to do is, if you want to make a square with a particular side length that isn't the midpoint, okay? Okay? So then what you're going to have to do is you're going to have to extend that line segment. So first off, I want you to extend your line segment out that far. So if that's the side length that you're going to make your square, you need to extend that out. Okay? Then what you're going to do is you're going to measure with your compass segment AB. Short under AB. Otherwise your square is going to be huge. Yeah. Okay. Okay. And then what you're going to do is you're going to go to the other side and you're going to mark we'll call it point F. What have I just created by doing that? What have we just created? By extending our segment, measuring AB, and then marking off BF. What have we created? What have we created? The bronze table, what have we created? Lawrence table, what have we created? What kind of line segment? Okay, all right. So far we've got that we've created a line segment. So far we're correct. What have we created? Bronze table, I've got to go back to you. They said we created a line segment. You got anything to add to it? Because there's more to it than just line segment. So we've created two congruent line segments. You would agree with that we've created two congruent line segments. Yeah. Do you guys agree that they've upgraded yours that we created two congruent line segments? Yeah? Okay, all right. So far now, here in the middle, we've created two congruent line segments. What does that mean? So far, everybody's right. Okay? What does it mean? What does that mean? What does it mean? Hey, we know that because they're equal. What does that mean? What does it mean? If we got two congruent line segments that are on the same line, what does that mean? You should know this. Okay? This is not something new. We've talked about it in this unit before. What does that mean? You guys up here, what does it mean? Say louder. Oh my God, say it louder. Which one's the midpoint? Why is B the midpoint? Because it's in the middle, right? Of two congruent segments, right? So, what property of a square do we need to have? We can do side lengths. We just did a rhombus. How can we make a rhombus be a square? What do we need to have? We gotta have a right angle. So how can I construct a right angle? Perpendicular bisectors, right? And what do we need in order to have a perpendicular bisector? A midpoint. So we just created the midpoint. Okay? So B is now the midpoint. Okay? So now what we're going to do is we are going to perpendicularly bisect segment AF. And what is that perpendicular bisector going to go through? It's going to go through B, right? Okay. Refresh my memory. You guys all got it in your notes somewhere. How do I construct a perpendicular bisector? Why we take notes, so that we can refer back to them, especially when we don't know something. More than half, right? So I've got to extend my compass, right? Okay, so I got to extend my compass for sure. Okay? All right, then what? Big arc? Then what? So we go off to point F then? Okay. Sid can't be the only one that's got these written in her notes, because I know you all got them, because I'm the one that gave them to you. Do I need the bottom arc? The second one. Yay or nay? Why not? Do I need it? Better put it in then. If we can't figure out if we need it or not, we better put it in. Okay? So it's there, and now I can connect them, right? We went through point B. That's a good thing, right? Yeah? Okay? Step 4 now, we're going to measure segment AB. Okay, so we're going to return our compass back to segment AB to that length. And from point B, I'm going to swoosh my entire square. Now that has given me point C. Next, go back to point A and swoosh it. Next, go to point C. Luckily, you don't have to change the distance of any of these because they're all the same. Oops. And that gives you point D. And there's your square. Yeah. All right, let's take a quiz. You can leave out your toolkit